Good morning. Hello, everybody. Hello. Oh, she's like the first one in there. Say good morning. Awesome. How is everyone today? Sore from shoveling all the snow this weekend again. My friend posted something the other day saying, oh, good. I'm glad it snowed because I forgot that the ground is actually, there's something underneath the snow. It was kind of funny. So tired, Cass? Yeah. You're feeling better though, right? I think you're saying that you're feeling a little bit better. That's good. All right, and Luna is making pancakes. She's not sharing, so I'm a little upset about that. She's making it for her sisters, but not bringing any here, so you know. Yeah, good, that's awesome. Weekends, how did you guys fare out this weekend? Anything fun and exciting to tell, or something just to share what you were doing? It might not be fun and exciting, it just could be, you know, something. You made pancakes yesterday, yes. Do you put stuff in it, or you just make regular pancakes? Or did you make it for your, is it a recipe for foods or just like regular pancakes? Cass and I went to Arian, and that's for, oh, that's awesome. Good, good. I know, I saw the Loomba. I like the Loomba too. I'm like, that's awesome. Good crew brought some other stuff. Good, good. That's awesome. Great. Anyone do any activity? Anyone go up to the hill? Did anyone do anything fun that way? Get up and enjoy some of that snow up there. Took your dog for a walk. Excellent. Good. Make sure you guys are logging all the stuff in the PE stuff, right? Want to make sure you're doing that. You skied on the weekend, and today you're you're competing. Yeah, that's right, Belle. Good luck with that. Friend came to visit you from Colorado. That's good. That's good. It's nice to have friends. That's fantastic. Good. I was supposed to, so last week when we had that massive snow thing on Saturday, I was supposed to go out with a friend. We canceled it because the weather was horrible. If you don't have to drive, like, why worry about it, right? So then we made it up for Friday, this Friday, and there was a total snowstorm again. And I almost said, forget it. I don't want to change plans twice. And then when I drove home, I was like, oh, this is really bad. So we're doing it this Friday coming up. So we're hoping it's not going to snow this Friday. And then I had a friend's birthday thing with some of the people I used to play ball with. And so that was fun to see some people. Like you see people on Instagram and Facebook and stuff like that, but nice to see them in face to face. And then some people I haven't seen since I stopped playing ball. So that was, some of them has been a while. So it was good. There was some cake. It was delicious. Ah, good. Okay. Oh yeah, and then I have someone called, I call her my second mom. I have my mom. And then I have my husband's mom, who's my mother-in-law and stuff. And then I have my second mom. And so when I started going to university, so I've known her since I was basically, I didn't move in with her right away because I went to Simon Fraser, but I moved in with her when I was about 19 or so, and I lived with her for a good 5-6 years or something like that, even after I graduated university and stuff like that. So I call her my second mom. She's the same age as my mom, but she's awesome. So yeah, and she bought my husband and I, with some other people and everything, we're all going to go down to the Cirque du Soleil show in April. That's down in Penticton. So that's our birthday gifts from her. So I'm like, that's awesome. So we're like front row at the ice one or whatever. So yeah, it's going to be kind of cool. We've seen a few in Vegas, and we saw one that was here in Kelowna one time. So, oh, awesome, Luna. Yeah, it should be interesting. I've never seen it on ice, so it's going to be interesting to see that. You have so many second moms. Oh, it's funny. Yay! Luna says she's back. Actually, she just talked to me. I know that. So, good. Okay, my voice is gone because of Saturday. I was talking over a crowd of people. My voice seems to go quite quickly. Now, as you get older, it doesn't stay there. It doesn't, and I'm not used to doing that very often, so my voice is a little scratchy. It comes in and out. Now, some reminders. So one reminder, PE and foods. Make sure you guys are doing all the stuff that you guys need to do for that. Don't forget, you know, record all your activity, that sort of thing. No class on Wednesday for science because on Thursday we're heading to KSS. You need to be there at 8:45, right? So no class on Wednesday. It's going to be the Thursday class. And two things from Mrs. Ward. One, the calendar's not working this week. For some reason, there's a glitch. Things aren't showing. So because of that, she just wanted to remind you that the link for the Dragoons is on the main page, not in the calendar. So if you're going to that or wanting to go for that or whatever it is, the link is on the main page. She wanted to let you guys know. And then basil. The tower has overrun with basil. So she's saying if you need it for your foods class or at home, or if your parents use it a lot, come by and get some basil, because she has a lot of basil that you guys can use. Okay. Is anything happening on Wednesday? No, Wednesday's nothing, because I'm canceling class. We're doing it on Thursday. We will have, I don't think so. I think it's just, I think you're just seeing Mrs. Ward on tomorrow. That's it. I don't think we did a flip-flop. No, we can't do a flip-flop on Wednesday, because she has some classes that are certain timed. So that's why our schedule isn't consistent like it was with math, because this semester Mrs. Ward has classes that she teaches live through other schools. And so when it, like for example, this week she's Monday, Wednesday. So she's teaching that class Monday, Wednesday, which means she can't teach you guys Monday, Wednesday. So we can't flip-flop her, because she can't flip-flop at the other school. So there's nothing on Wednesday. Okay, yes, a homework day for sure. And it was pointed out to me by a couple people that I just wrote in the wrong date for that home lab. Remember I said I was giving you guys a week and a half. I had it due for today. It's not due today, it's due next time. So I just changed that for you guys just to get rid of any confusion. Yeah. And like I said last time, guys, substitute stuff. So I know it says beakers because it's actually written like an actual science experiment, science lab. So it's going to say the Immermatter flask, it's going to say the beakers, it's going to say that stuff. Use a glass, like use something to change and improvise. And most of the materials are stuff you should have at home. Like most people that bake will have baking soda and vinegar, and antacids are super cheap to get. You can get them anywhere if you don't have, or borrow from somebody. So it shouldn't be anything that you have to go out of your way to get anything for. Old Spice bottles, yeah, something like that, good. You're supposed to try to weigh it, so that was part of it. So like I said, you guys are welcome to come in here and arrange a time to come in and do it with the scale that I have here. So that was something you could do, or see if you can borrow from somebody. But yeah, try your best to do it. It's just a fun experiment, and it's more the process I'm worried about than actually the final results. I just want you guys getting immersed in the scientific process and doing all the parts that make science, right? And just doing all that sort of thing. Yeah, perfect. Yeah, that's excellent. Okay. Would Wednesday work since we don't have class? Yes. Yeah. Yes, you're supposed to do an actual lab with that one. Yes, for sure. Okay, good. So just let me know who's at KDT. Just maybe in Moodle message, shoot me a message when you think you're planning on coming, just so I know, and then I can just make sure I'm ready to go with you there. Okay, good. Okay. All right. So coming up this week, we have Wednesday afternoon, 1:30 to 3 o'clock is the art gallery, and then March happens on Thursday. So crazy. So we have on March 1st is Thursday. That's when you guys are going with me to KSS. And then March 2nd is H2O, little swim time, swim. Was it supposed to be done in the worksheet or with both? Both, yeah. So you have to do a little bit of a lab write-up, and then you have to do the worksheet stuff on there. Yeah, oh, yeah. Okay, hence why on the site it has that lab format sheet was posted there as well, so, okay. All right, today's one. We're gonna talk a little bit of conservation of mass. We're gonna get you guys to do a little bit of playing around with a balancing simulation activity that's online. Yeah, and I emailed you back, Jocelyn. Yeah, I emailed you back. And then we're going to do a demo today. So Magical Merle is going to help do a little demo. You're going to have a couple practice worksheets. I'm providing you the keys with that, the answers with that, so you can do a little practice, see how you're doing. And then there's one that I want you guys to hand in. So I did mention that there is something that I wanted you guys to print off for today's class. So there was two things, I believe. There was the notes for what we're going to go through today, and then the demo, there's some stuff you're going to write down. So if you weren't able to print some of that off, you're going to have to kind of catch up with that. When we do the demo, and if you weren't able to print it off from the demo, you'll just have to write it down and then put it on after. Okay? Oh, that being said, Just a general comment, when you guys are writing your subscripts, so those are the numbers that are like really at the bottom, make sure it is obviously a subscript. Some of you guys are writing your numbers too big, so it's actually looking like a full-size letter number, or you're writing them on as an exponent, or you're writing it actually like a number. So you have to make sure it's a little more clear. I'm not overly strict on it, but I don't know what grade 11 or 12 is going to look like for you guys. So you want to make sure that you're not making it confusing, because technically if you put a 2, you're going to learn today, if you put a big 2 versus a subscript 2, it makes a huge difference, and you're going to learn that today. So it's really important that you make a small number and stuff like that, okay? All right, so conservation of mass. So we're going to start off with the notes and go from there, okay? All right, so reminder, so we looked at chemical change last day. Chemical change, there's new compounds are created. Typically that's what happens. You start with some originals, they do some configuring, and then something else happens on the other end. So that's usually what that happens in a chemical reaction. Something new is usually produced. It could be heat is produced, it could be light is produced, it could be a new substance is produced, something like that, something new is created, okay? So I tried to put the stuff in yellow that you put onto your note sheet. So keep an eye out for that. So that chemical is the first answer on the sheet. Okay, so it says blank change means new compounds are created. So it's chemical. So I tried my best to do that. I'm not promising you that I was able to do that with everyone, because I forgot sometimes. Okay, are you guys with me? Hello. Hi. You guys good? Yeah, there we go. Oi! Okay. Sean, what? Oh my gosh, my voice just squeaked there. Okay, good. So the total mass of the reactants must equal the total mass of the products. This is the law of conservation of mass. So that's what this is. And the lab that you guys have to do, the demo I'm going to show you today, I'm not going to do that too much, but the demo you're doing and what we're going to talk about today is really going to look at what you start with, the mass. Let's say it's 10 grams. We start with a log, we weigh the log, and whatever, it's 10 grams. That's really light log. It's a stick. Let's make it a stick. And then after we burn it, if we have it in a closed system, then the heat, the light, the burnt piece of the stick, everything put together will stay 10 grams. Nothing's created or lost. Now, if there is a case of something's lost, it means it wasn't a closed system. It was open, meaning that the heat got out or the light kind of ended up going elsewhere and turned into heat and disappeared. So that's the difference why sometimes it won't match. It just means it wasn't a perfectly closed system. Okay? All right. So yeah. So this is just sort of the formula. So the total mass of the reactants is equal to the total mass of the products. So that's the next couple pieces on your note sheet, guys. So I'll give you guys a few seconds to write that. And I got a message here. I'm going to check that out. All right, so hopefully that was enough chance for you guys to write that. Yes, you do, guys. So it says law of conservation of mass on your sheet of paper, and then there's a spot to write stuff, and then I have an equal sign, so it's literally what's on the screen there, okay? What is number 2? What do you think? Conservation of mass, atoms just arranged. Yeah, so that one's just conservation of mass is number 2. Perfect. All right, so that's a really big important message from this, and we're just going to look at that a little bit more, and we're going to look at how you see what the reactants are and what you see the products are, and then making sure that there's the same amount of items. So if I started with one calcium atom, I should have one on this side. Okay, if I have 4 on this side, I should have 4 on this side. So we're going to look at how to kind of make sure those are balanced. So just like when we did algebra balancing, same thing with conservation of mass. Okay. All right, so law of conservation of mass, we have a guy called John Dalton. So 200 years ago, he realized that atoms are simply rearranging themselves during chemical reactions. So that's one of the things that he noticed. So what I want you guys to do, I'm going to let you guys go and look at a clip right now. And stupid Miss Mac did not write down how long it is. I'll give you guys 5 minutes. I can't remember how long it is. I'll give you guys 5 minutes, and I want you to go to the Moodle site, and there is a clip there under today's date that I want you guys to watch, and I'll see you guys in 5 minutes after you watch that, okay? Okay, welcome back. So super interesting how the people that have these minds just boggle me. Like, it's just insane how all of a sudden they just start trying things and start figuring things out and come up with a hypothesis or whatever it is, a guess, from, well, it would be probably a hypothesis just because they have some background knowledge, right? And then they come up with this idea and then they test it and they're like, oh my gosh, this happened, or disproved this, or like, hey, that's what that must mean then. Like, it's just, their minds are crazy. So, sorry, what was the blank with the one starting with but? Conservation of mass. Okay, yeah, so really cool how he was able to figure out that what you start with is what you end with. It's just things are just rearranging that way. So then we have Antoine Lavoisier and his wife Marianne, which I spelt wrong, I just noticed, developed in chemical reactions, the atoms are created or they're not created or destroyed. They're always going to be there. So Dalton went, okay, they're just rearranged when there's a chemical reaction, and they went further with this conservation of mass and said that it's now that nothing's being created and nothing's being destroyed. It's just that rearrangement, which seems like stuff is disappearing or stuff is being created. So these guys kind of, they piggyback off each other, right? That's the fun thing about science and learning. People learn from everybody. It's important to share. Okay. So this makes sense because atoms cannot be created or destroyed. So that was your the next points that you guys need to write up. So atoms present at the beginning of the reaction have to be present after the reaction has taken place. Okay. So it's not like there's something brand new happening there. So what happens is, and this is going back to Dalton, so I'm combining both of their stuff in this, the atoms are rearranging themselves and forming new bonds and creating different products, but it's the same atoms, okay? And we're going to learn how they do that when we actually start balancing equations. We're going to see how that goes, okay? So when you write a chemical equation, the number of atoms of each type must be the same on either side. The equations must be balanced. So what I have reactants on one side of the balance, I have to have the same weight, mass of products on the other side of the balance. You want to see that again? Watch that. Reactants balanced, and then products balanced on the other side. Yes, yes. The equal sign was the total mass of the reactants is equal to the total mass of the products. So that's the one that's equal. Okay, so in about 3 or 4 slides there, I said the exact same thing. So hopefully we're kind of now got it glued into our head that the conservation of mass, nothing new is created, nothing is destroyed. Atoms that are on one side, same atoms on the other side, they're just arranged. Mass on this side is exact same mass on this side, okay? So that is, let's see that again, reactants, yeah, and products, yeah, okay. So now we're going to learn how to write these chemical equations when there's been a chemical reaction. And like we said, it has to be balanced. So we have to, their job is to figure out what's the reactants and products and all that kind of stuff. What we're going to do is worry about making sure it's balanced. And if we have 4 sodiums on this side, we need 4 sodiums on this side, okay? So chemical equation, so we're in the middle of the page there on the other line. So chemical equation is used to represent a chemical reaction, okay? So for example, oxygen and hydrogen in a balloon react to produce water. So we have hydrogen and oxygen, we have them on one side, and then the reactant is water. So the same number of atoms has to be on both sides, and nothing new is created. It's still oxygen, still hydrogen, it's just water, they've just joined together differently. And so we have the reactants are the original products, which we talked about in the last slide there, and sorry, not original products. Reactants are the original compounds, and then the products is what's created from that chemical reaction, okay? So that's the first couple lines there under that section. And so what I'm going to do is show you the 3 ways that chemical reactions can be written. It's not going to appear 1, 2, 3. It's going to appear, I'm going to show you 1, talk about it, then I'm going to show you 2, talk about it. So you might have to flip back to write those three things on the next spot, okay? So number one, there are three ways of writing them to show how there is a reaction with the reactants and how they create a product, okay? So number one, word equations. So that's going to be the first blank there, three ways to write. One is just with a simple word equation. So here I have hydrogen plus oxygen creates water. So we have two reactants and we have one product. So we have hydrogen reacts with oxygen, which is another reactant. They react to produce the product of water. So this is just a simple word equation. We're not looking at how to change it into its formula. We're not looking at balancing it. We're not looking at any subscripts. This is just a word equation, okay? So that's all there is to that. Number two is something called a skeleton. He's on my shoulder. That looks awesome. Oh, that was so cool. He was totally on my shoulder, like a little skeleton shoulder. So we have skeleton equations. So these ones are a little bit, this is kind of the medium kind of spot. So skeleton equation is only showing the atoms. So we're not worried about balancing them yet. So the first one was just the words. So it said hydrogen, oxygen equals water, basically. This one, what we're looking at is just the atoms. So hydrogen, which is one of the ones that all have the twos. Remember, you guys had to make a little kind of saying out of those 7 of them. So we have H2 plus O2 equals H2O, okay? And so they have to balance. But it's not balanced right now. This is just called a skeleton equation. How do we know it's not balanced right now? Can someone look at this equation and tell me, how do we know it's not balanced? And that'll give you a clue how we actually start figuring out how to balance these. What on here is my clue that it's not balanced when we look at that? The skeleton's talking to me. I know, isn't that awesome? It's the O, yeah, the oxygen. So on the left side, on the reactants, I have 2 oxygens. But on the right side, I only have 1 oxygen. So here's the thing that you have to be careful about, and this is where you're going to learn about subscripts and actually having a big coefficient number. The subscript tells you how many of that particular atom there is, but what we have to do is balance the whole thing using coefficients. If I put a 2 as a subscript under the O, that changes what is no longer water. H2O2 is no longer water. So you don't change the subscripts when you're balancing. You change a coefficient, and we're going to learn about that in a second. Okay? So this is a skeleton one. We've just written down the atoms. We have not balanced it. Everyone say goodbye to skeleton guy. Bye, skeleton guy. You're so cute. Hello, happy guy. Okay. So the third one is called balancing the chemical equation. So this is where we start looking at the coefficients and making sure that we have the right number of atoms on each side of the equation. Okay, so in this case, so you guys were telling me that we didn't have enough oxygen. So I want you to look at this here. So we have, I put some 2s in there. So we were saying, oh my gosh, on the reactant side, we had 2 oxygens, okay? But when we were over on the product side, we only had 1. So the only way I can fix that without changing what the product is, if I put a 2 as a subscript, it's no longer water. I still need it to be water. But if I put a 2 as a coefficient, it basically means now I have 2 oxygen atoms. Perfect, because I have 2 over here. But that then creates a problem, because now I have, how many hydrogen atoms do I have here now? I have the 2 here, and I have the 2 coefficient, right? So now I have 4 hydrogen atoms. I'm now not balanced over here because I only had 2 to start with. So that's why there's a 2 here. So this is how you balance an equation, is that you start adding coefficients to try to make the atoms match. And then as you do this, you might have messed up one. So we fixed oxygen, but then we messed up hydrogen. So then we have to go back over here and see if we can fix hydrogen. That actually might make more of an issue, so then we might have to go back over here and fix. So sometimes it's a lot of back and forth trying to find that perfect combination of adding coefficients to make everything balance, okay? So a coefficient is a number that is placed in front of a chemical formula in a balanced chemical equation. So that's the yellows, okay? Those are called coefficients. We learned about those when we were doing algebra and all that sort of stuff, okay? So coefficient is what goes in front. And you always use whole numbers. Always use whole numbers, okay? All right, so Coefficients indicate the number of products in the reaction, okay? And if you change the subscript, you're actually changing the what of the substance. So if you change the subscript, does anyone know what that you're changing? The word, you could probably have a few different words, but I chose the word that starts with an I. Does anyone know what word would work there? So if you change the subject, you're actually changing the something of the substance. I started with the I. Changing the value, not necessarily the value of the substance, because they're all valuable, Belle. They're all so important, so important. I just put the word identity. It's changing the identity of the substance. So if I change the subscript, it's no longer water, okay? CO and CO2, totally two different things. Carbon monoxide and carbon dioxide, completely two different gases, right? So same thing. And then hydrogen peroxide is when it's H2O2, that's hydrogen peroxide, totally different than water. Okay, so you don't want to change the subscripts. When you're balancing, you want to change the coefficients. Okay, so right at the bottom of the page, it wants you to do an example. So what I would do, let's go back here. I would, with my skeleton friend, write this down. So write what the original atoms are. So we're at the bottom of the first page. So at the bottom of the page, write down what it originally was. So H2 plus O2 plus equals H2O. And then what I want you to do is put the 2's in the front in the right spot to show how that would balance, okay? And then have it look like that. And if you want, what you could do is, for example, put a 2, like maybe off to the side, go H2O2 is hydrogen peroxide, and then say don't change the subscripts or something like that. Anything that you need to remind yourself that you're not changing the subscript because that changes the product. It changes whatever you're working with, okay? And that's the end of the first page. All right. Okay. Goody goody gumdrops, all right. Okay, so just a reminder, the only way to balance equation, change the coefficients. If you change the subscript, you'll change the identity of the substance, okay? So here's my example. Wrong way, don't do that. That's hydrogen peroxide, don't do that. Wrong, 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 do not do that, okay? So you're only doing the coefficients. Okay, so remember we were talking about the diatomic molecule, so that was, I was mentioning how there were 7 of them that have the 2 below it, and you guys had to come up with your little saying. So mine was happy ostriches fling bread into nasty clowns, okay? And then I have no bright or clever friends. I love that one. That's one of my favorite ones. Does anyone remember what yours was? Because I wasn't here. You guys had, Mrs. Wyatt taught you guys this lesson. So I never got to see, and she didn't record it, so I don't know what any of your guys' examples are. Does anyone have, remember what there was? Someone created a funny one. Oh, I wish I got recorded because I want to see what they were. Yeah. Do you remember what it was, Christiana? Her. If you can find it, maybe you can share it when you, yeah, perfect, go ahead, see if you can find it. I have no butter or crunchy fries. That was good, I like that. That was awesome. Oh, fries, okay. I like crunchy fries is good. What do you want to go back to? This guy? I have no butter or crunchy fries. That's actually a pretty good one. That will help you remember that one pretty quickly. Good. Yeah, so I like the one I have no bright or clever friends. So that will help you remember the ones that are 2, that are the diatomic ones. The first one under coefficients. It's reactants and products. So the original compound is called a reactant, and the one you end with is called a product. The number. So KDP, that indicates the number of the compounds. Okay. Okay, so you're going to need to remember these because when you're writing the original atoms, if it's one of these guys, so remember when it was hydrogen plus oxygen, they just didn't write H and an O because H is a diatomic, so it's H2, and O is a diatomic, so it's O2. So that's why you need to remember these when you're writing it. So if it's bromine, you can't just write Br, you have to write Br2. So that's why you need to remember that. Friends bring clumps of hair inside. Oh my gosh, that's disgusting. Oh my gosh, that's awesome. Cool, good job, that's great. Okay, So now what we're going to do is learn about writing and balancing them. So you guys got to see how that works, right? So you write the atoms down in the skeleton format, and then you have to try to make sure the number of atoms on both sides are working. All right, so only show the atoms, not the number of atoms. Okay, so that's why you're just writing hydrogen and you're just writing oxygen. So that's your first line on page 2. So that space, skeleton equation. So skeleton equation only shows the atoms, but not the number of atoms. So that's a skeleton equation. A balanced chemical equation shows the number of atoms and their quantities. Okay, so a skeleton one is just showing the atoms, but not how many there are. It's just saying it's hydrogen and oxygen. That's all it's saying. It's not saying how many there are. And then a balanced one is actually showing how many atoms there are and then the quantities that there's going to be of them. Okay? So balancing assuring both sides of the equations has the same number of atoms. Okay? So you're on the third point on your notes. So it says balancing assurance that the number of each atom is the same on both sides. And always use the smallest whole number ratio. And so what that means is if I could go 2, 1, 2, I shouldn't do 4, 2, 4 because you want to always, it's almost like a reducing thing. You always want to use the smallest one. Yeah, I could go 10, 10, 10 and it all matches. Well, why would you do 10, 10, 10? You might as well go 2, 2, 2 or something like that, right? So go back to what? We're on the top of page 2, so I'm not going to go back right now. We're just going to stay on this. This is we're on the top of page 2. We just got to keep moving on, okay? Yeah. It's going to be recorded, so you can come back and catch that in a second, okay? So it's all on this screen at the top of page 2. Yeah, and the bottom of page 1 was just writing down the example, which was a little bit ago, a few slides ago. All right, so on yours, I have an example that says methane and oxygen produce carbon dioxide and oxygen, okay? So a Bunsen burner works with methane gas. It burns the oxygen to produce carbon dioxide and water. So this is where if you measure the mass and you don't have a closed system, you're going to lose the carbon dioxide. And sometimes water vapors do escape as well. So that's why sometimes conservation of mass is going to seem like it's not working because the closed system's not there or it's not efficient. Okay, so you write the balanced, so what we're going to do is write the balanced equation for that. So on your sheet of paper, I'm going to first of all show you guys the written word equation. Okay, so you don't worry about on your sheet of paper about this, but this is the first one. So we have methane plus oxygen, which creates, these are the reactants. So it says methane when it burns, oxygen, it creates carbon dioxide and water, which are the products. Okay. So then we get to step 2 is now we're going to look at the skeleton equation. Okay, so now we're going to take the names of them, methane and water and carbon dioxide, and we're going to replace them with the actual atoms. We're going to put in the actual formulas of what they are. So methane is CH4, it's on your sheet. So it says skeleton CH4, it says plus O2, which is the oxygen, because again it's diatomic. Carbon dioxide, CO2, plus water, H2O. So you guys have that on your sheet. What I want you guys to, what we're going to do is I'm going to show you the process of how to balance these out. And I'm going to show you a grid method. If you like the grid method, go for it. If you don't, like I don't use a grid method, but it's just going to show you step by step how to do it. If you like it, use it. If you don't like it, just trial and error and figure it out. Put a 2 here and go, oh shoot, now I got to put a 2 here. Oh, now I have to put 3 here. Now I got to put a 1 here or whatever, okay? All right, so now we're going to try balancing. So we need to count the atoms of each type in the reactants on the left side, and then we have to count them over on the product side, okay? So right now, when we look at this, I'm going to show you the table here right now. So we have on the left side, so we have carbon we're talking about. On the reactant side, there's one of them. So if you see here, there is 1 carbon. If we look on the product side, there's only 1 carbon. Okay, so that's actually pretty good. So that's why it's like green thumbs up, you're awesome. And then we have the H. Here we have 4 on this side, which matches the reactants of 4 here. But if we look over on the product side, we have 2. So that's why it's red thumbs down, doesn't match. Then we have oxygen. We have 2 on this side in the reactant side, and then on the product side we have 2 here plus the 1 here, which makes a total of 3. So they're not matching. So right now our skeleton equation is not matching, it's not balanced. So what we need to do is now start adding coefficients in order to figure out how we can make the same number of atoms on both sides, okay? And carbon's good. It doesn't mean that we're going to mess around with carbon a little bit in order to make the other ones match. So that's going to be the part that sucks. Like you're like, yes, carbon's matching. You're like, woohoo! But then when you start changing the coefficients, you might mess it up and then you have to redo it. And yeah, so sometimes that happens. So it's a sad day, sad day. Okay, so what we're going to do is we're going to start by going, okay, we were short 2 hydrogen atoms. So let's try this. Let's add a carbon. You guys can just watch this. You don't have to be doing anything for this. So you're like, okay, I had 4 hydrogen on this side. I only had 2. So let's add a 2 here. Let's see what happens. So if I add a 2 there, yay, I got 4 and I got another green thumbs up. But guess what that did? That made me now have 2 oxygen, and now I have 2 oxygen here, which means I have 4. So I now still have too many oxygen. So I'm not completely balanced. I'm getting closer, but I'm not completely balanced. So it says, remember when you put a coefficient in front at all of the compounds. So it's not just the 2 is not just affecting the hydrogen, it's also affecting the oxygen. It's just like feed the chickens, right? You guys learned that in algebra, feed the chickens. Okay, so we have to now keep going. We have to try to fix the oxygen. So here's one of the possible fixes. Well, instead of putting a 2 in front of the hydrogen, why don't we put a 2 in front of the oxygen in the reactants? So we have, oh my bad, there should be a 2 there. Sorry, there should be a 2 right in front of that. I didn't put it back in. So we have a 2 here, and what that did was allowed our hydrogens to match, okay? Actually, you know what, I'm going to fix that right now. Let's put a 2 there. Oh, you know why? Because it's black, that's why. It is actually there, but it's just not showing up. There it is! Okay. All right. Easy fix. There we go. Okay. So now we have to balance out the oxygens because we didn't have enough. Originally it was 2 and 4. So now if we go over this side and put a 2 there, now we have 4 on this side, we have 4 that matches, and guess what? Now we're completely balanced. So we have everything matching. So on your sheet of paper, on the balance part, so the skeleton one you don't touch, we're going to leave it, and then on your sheet of paper, put the 2 2s in front of the spots of what we just did there. Okay, so this is just a table method. Do you have to draw a table every time? Do you have to write the titles? Do you have to do it exactly the same way? You do however you want to do it, guys. This is just a very concise, organized way of figuring it out. If you want to do it in your head, do it in your head. Okay, there's no right or wrong way to do this as long as you balance it out and make sure the atoms match on the reactant side and then on the product side. Okay, so what I'm going to show you now is some of the tips to balancing this. It is on your worksheet. You don't have to fill anything. It's at the bottom, but it's there for you. But I'm just going to go over it now with you guys. So 1, you need to multiply each compound by the coefficient to match the number of atoms. Do not change the subscripts. These are just little tips, right? Balance compounds first and then the elements last. So compounds are when you have a couple elements put together. Okay, so H2O is a compound, but hydrogen's an element, oxygen's an element. So it says try to work with the compounds first, the ones that are put together, and then do the elements last. Balance in hydrogen and oxygen last is better, and it's just a method that they found works best. If you have an N's and CA's and CL's, do all of those first, try to balance those out, and then look at hydrogen and oxygen last. Is it foolproof? Do you have to do it that way? No, it's just a suggestion. It usually works better that way. If a polyatomic ion, so that's those ones like ammonium, which is NH4, or methane and stuff like that, the ones that are locked in that formula that you don't change. If it appears in both a reactant and a product, think of it as a single unit. So don't try to separate. So NH4, don't separate. N is 1 and H is 4. NH4 is 1. So if you put a 2 in front of it, it's 2NH4. That's what that means. It doesn't mean all of a sudden now you have eight hydrogens. That's not what that means. Trial and error, sometimes you just have to be patient with what you do, and then always double check. So after you think you got it balanced, do it again and make sure it's all working out. Some of the equations get quite long, and some of them have a couple different places where they have oxygen, or a couple different places where they have carbon or whatever. So you just have to go back and do that. Okay? So talk to me, people. How are we doing? How are things going down there on your end? Okay? So we got to see two equations get balanced, and it's just a little bit of trying to figure it out. And again, like I said, it's up to you guys what method you guys want to choose to do that. On your sheet where it says states of matter, I've just put this, I didn't put it in my slides, but what I want to do is just make sure you guys understand what some of that is, and you would have seen it prior to this. So it has aqueous or dissolved in water, solid, liquid, gas. What do you think solid, liquid, and gas, what would you think letter abbreviation would be used next to a compound or next to an element to indicate its state? What do you think you would use for solid to indicate it's a solid? What letter? S. Good. Liquid, what would liquid be? Yep, liquid would be an L, and what would be a gas? And some of you guys saw that. Remember, one of the worksheets asked you to have a fluorine gas, and some of you guys had to put F2 with a G in brackets. So that's an example of that. Aqueous or dissolved in water. It's two letters. What letters? What two? Yeah, good. Thanks, Katie T. AQ. Yeah. So I just wanted to put that there for you guys so that you could test that out. So we're going to do one here. I'm going to get you guys, I'm going to show it to you, and then I'm going to get you to try it on your own to see if you guys can balance this. Well, you can. I know you can. So we have sodium. Very, very volatile. Not a good thing on its own. Okay, you don't want to interact with sodium on your own. Chlorine gas. Very bad. It's very bad. Notice how different they look. Okay, one's a gas. You know, they're totally different substances. One's a white solid. One's a green gas. Very both volatile. They react quite strongly. When you put them together, they become table salt, which is totally fine, right? So that's the crazy part about chemical reactions. You don't know what's going to happen. Here's what blows my mind. Somebody did this. Someone went, let's take this really crazy sodium and let's take this chlorine gas and let's put them together and let's eat it. Let's see what happens, right? Like, it's just, these people, their minds are just, they blow my mind how they're so creative that way and figure things out. Like, it's just, it's awesome. I'm so glad there's people like that that can do that for us. Yeah, I know, right? Let's see. This will kill us. This could kill us, but let's just eat it. Let's see what happens. All right. So what I want you to do on your sheet of paper, I've given you guys basically exactly this. And notice I have S's and G's, so it's showing you what state they're in. So we have a solid sodium, we have a gaseous chlorine gas, and then it creates table salt, NaCl, and that's a solid. So what I want you to do is, looking at the skeleton one on your sheet of paper, I want you now to figure out what the balanced equation is. So I'm going to give you guys 1 minute to work through that, and then we'll go with the answer. And it's not too difficult of one. Okay, so 1 minute, we'll be back and we'll see what your answers are. Okay, so hopefully you're able to do some trial and errors. If you didn't get finished, that's totally cool. So when we look at this, what is the problem? What's the problem that's stopping this from being balanced? What is the element or the compound, well, mostly the element, what is the element that's having an issue? Yeah, so we have the chlorine gas, there's two of them, but on the other side, in the product side, there's only one. So what did someone come up with? What did, I know it's just a little bit of typing, but maybe just put your coefficients, put the number for Na, put the number for Cl2, and then put the number for your product. So if you thought it was 3, 4, 3, just write that in. Okay, good. So we have, don't worry, I don't think. All right, perfect. So we've got 2 there, 1 there, and 2 there. We got 2 there, 1 there, 2 there. Perfect. Good job, guys. So we needed to put a 2 in front of the product so that we could have 2 CLs. We needed 2 CLs. That was our problem. But guess what? That matched, which is really good, but then it created another problem. It created 2 sodiums on this side. We didn't have 2 sodiums on this side, so we had to add a 2. And then you just go back and double check. Okay, good. Yeah, no, you can't do a subscript on this, but yeah, we get what you're saying. Good, good, good. All right, so what I'm going to do now is I'm going to leave you guys with 3 questions to balance, 3 formulas I want you to balance, and then I'm going to let you guys, after that, have some time to play the simulation game that is on the Moodle site, okay? So I'm going to leave this up on the screen, and what I want you guys to do is you're going to balance it. I've made a T-chart below it so you can write. You don't need to do a T-chart if you don't need to. It's up to you. It's just an example of something that you can do. So what I want you to do, there's 3 of them there. I want you to balance those 3, and then when you're finished, I'll come back to it. After you're finished that, whatever time is left after that, I want you to go play the balancing chemical equations simulation. And like I said, that's on the Moodle site. So there is an introduction one, or you can just go straight into the game and figure it out, okay? So you have 15 minutes. I'm going to give you 15 minutes to do these 3 questions, and then whatever time you have left with that 15 minutes, go do that simulation game. Doesn't matter if it's a gas or a solid. No, no, not at all. Just depends if it's a diatomic thing or not. Yeah. Okay, so I'm going to give you 15 minutes. When we come back, we're going to have a little demo. So if you haven't printed off that, the little, I think I called it a demo on the Moodle site. If you haven't printed it off, print it off, or make sure you have some paper to write down the results. We're going to do a little quick demo after we go over these answers. All right, so I'll see you guys in 15 minutes.